Okay, good evening, everybody. Um, so welcome to my channel, and tonight I'll be taking us on C programming. This I'll be starting from where we stopped um on our last meeting, which is on C programming compilations. Okay, so I'll quickly brief us on what we did um last time on the C programming compilation. I'm coming. Let me quickly share this link so that I can start off immediately. And I believe everybody can hear me, Abby. I don't have light here, so I'm basically using my phone to do this. So bear with me. Okay, I'm coming over. Okay, so you can hear me loud and clear. All right. Good. So I'm going to be briefing us on what we did the last time. So that for those that are not in the meeting then and have not watched the video I posted before now, okay, so you can quickly have an idea of what we are doing here, and then so that you can flow with us. Okay. Okay. So we are in the compilation, the C compilation, that is the compilation component on C programming. Okay. And then we said compilation involves components that works together to translate source code into an executable machine code. Okay. Now compilation, like I said, involves several components. So there are different components that comes together, okay, and then make this particular program, okay, to be translated, like their source code being translated into an executable machine code. Okay, now we list out different components like we've always seen. So most of us have seen, I've heard of the preprocessor, the compiler, the assembler, and then the linker itself. Okay. Now, so like I said during our last meeting, so I took my time to explain every bit of information about the preprocessor. Okay, so there was no time for us to continue, like talk about the other aspect of compilation component, which are the compiler, the um, compiler, what is it called, assembler, and then the linker. Okay, so let's go now. Preprocessor, I said, is a component, it's a compilation component that perform processing tasks, okay, on the source code, so before the actual compilation process begins. All right, so the first aspect of compilation, or the first stage of compilation, start from the preprocessor. Okay, and what it does is that it takes your source code, all right, and then convert it to a particular file called the intermediate file. Though that file is not actually called the intermediate file. Now I'm going to be telling us why it is called the intermediate file. Okay, so as we go on, I've been exposing to us the essence or the reason why those files are called intermediate files. Okay. Now, your source code is what the preprocessor first processed. Okay, so at the end, it will not generate this particular file, which I said is an intermediate file. Okay, so uh, okay, like I said, as we begin, I'm going to be telling us the essence or the reason for. So the reason for this particular file called intermediate file. Please, if you can hear me, I want you to just say something. Okay, so if you can hear me, just type something. Okay. So like I said, the first stage or the first phase of compilation start from the preprocessor, okay, and not the compiler. Okay, so many of us confuse this whole compilation stuff down to only the compiler. Okay, now there is preprocessor to start with, there's a compiler to continue with, and then there is an assembler and then linker. And sometimes you might just be seeing three, which is the preprocessor, the assembler, but then it can be splitted into four or three, depending on how it's being explained. Okay. Yes. So like I said also about the pre-process pre-processor directives. Okay, so when I made mention of the okay, so I explained the preprocessor directive, which I said the command are processed by the preprocessor, right? So they are actual, like they are special instructions that are being interpreted by the preprocessor itself, okay, which is used to control the compilation process. Okay, so preprocessor directives are instructions, they are special instructions, they are not just instructions, but special instructions compilation. Okay, and what it does is that they are used to control the compilation process. This preprocessor stuff is kind of deep. Okay, if you want to know a little bit about it, you can go and watch my last video. Okay, now here is the commonly used preprocessor. So I gave us different kinds of preprocessor directives. Okay, where I made mention of includes directives, I made mention of the macro definition, and I made mention of conditional compilation. Okay, so I talk more on all this stuff. Okay, but then I think I'm going to be leaving this. So if you want to know more about this, you can go back to my last video and then check out yourself. Okay, it's there. All right, but so we've talked about the preprocessor. Now we are going to be going to the second aspect of compilation process, which is compiler. We know about the preprocessor, and then we know about the compiler, we know about the assembler, and then the linker. Okay, so tonight we are going to be dwelling on other aspect of the compilation component. Okay, now the preprocessor phase is the starting point, okay, of compilation process. But then when the where the actual compilation phase occurs is within the compiler. Okay, so for the fact that the compilation phase, okay, starts, okay, from preprocessor. Okay, now that is not all. Now the most or the actual place, the actual compilation phase occur within the compiler. So the compiler do most of the job, okay, when it comes to all these compiling processes. Okay, so the pre-processing phase is the starting like the processing phase. Okay, is the starting point of the compilation. But then where the actual compilation phase occur is within the compiler. Okay, so this is why the compiler is sometimes you hear people calling the compiler the compilation phase. Okay, because they will just summarize everything and call it the compilation phase because that is where the actual compilation begins. Okay, now compiler converts the intermediate file generated by the preprocessor into an assembly code. So I'm going to be explaining the what intermediate file means. I'm going to be explaining what assembly code means, and then we are going to be going deep into these things. But we are still going to, finish up of everything. Now, before I proceed, let me quickly talk about what intermediate file simply means. Okay, because during our last class, I only talk about how the file is being generated, but then not its function. So if you go back to that last video, you see where I talked about how the file is being generated, but then I didn't make mention of the function. Okay, so I didn't make mention of the function. But here I'm going to be breaking down everything um, about this particular intermediate file. Okay, so let's go. Now, intermediate file can also be called intermediary file. So don't be confused when you see something like when they're trying to call intermediate file an intermediary file. All right. Now, the essence of this generated file, which is called intermediate file, is let me say the essence, okay, is to assist in the translation of the source code into a machine code. We all know, or we know what machine codes are. Okay. Yes, I'm going to be talking about it. I'm going to be talking about when I started explaining all this binary function stuff. Okay. Now, the essence of this particular file called the intermediate file is to help to translate the source code into the machine code. Now, if you notice, your source code is not a machine code, okay? But then what the intermediate file does is that it helps to translate this particular source code, okay, your source code at this moment, into a machine code. Now, machine codes are binary, all those 1 0 blah blah blah. All right, now your source code is human readable codes. Okay, so that's why you are able to understand what you are doing. But then when it comes to machine code, it's only like can only be understood by the computer itself. Okay, but listen, I never say my intermediate file generated, okay, are called machine code. I only said it every process of translation, that is process of translating the source code itself into the machine code. Now, in fact, before then, what is the meaning of this? What's the meaning of if you want to look deep into intermediate? What is the meaning of intermediate? Okay, as a word itself, like the meaning. Now, intermediate simply means occurrence between two positions. Okay, like something occurring between, let's say, A and B. So the occurrence between those two objects or those two integers are called intermediate. Okay, now by implication, it means that for every stage during compilation process, intermediate files are being generated between two compilation components. So for every stage during the compilation process, for every stage, let me say between preprocessor and then the compiler and then the assembler, okay, and then assembler and linker, every point in time there is a generation of intermediate file. Okay, so that is why I said for every stage during compilation process, intermediate files are being generated between two compilation components, but then not actually called intermediate files. So that's why you just they only use the terms intermediate file during the code. I mean, yes, during the compilation process between the preprocessor and then the compiler. So they stop using the intermediate file. So the next thing you hear is that um, assembly code and then object code. Okay, so the essence of, like I said, for every point in time, there is a generation of what intermediate um, code between two components. Okay, but then they are not actually called intermediate file. They are being called another thing entirely, which I'm going to be showing us very soon. Now, to further prove my point, okay, so let me quickly list out the various type of intermediate file. Now, this is where we are going. Okay, now this intermediate file we are talking about, remember, we are still in compiler. Okay, by the time I'm done with the intermediate file, you will understand everything as regard to all the compilation components. Now, me talking about compilation component, I'm talking about the preprocessor, the compiler, the assembler, and then the linker. Okay, so by the time I'm done with the intermediate file, you'll be able to know every bit of information about this whole compilation component, which can also be called compilation model. Okay, now let's go. Like I said, let me quickly list out the various types of intermediate files. Okay, I believe we all know what intermediate files are. All right, so now the first one here is pre-processed files. So the first type of intermediate file are called pre-processed files. Now, these are files generated after the pre-processing stage. All right. Now, when the preprocessor receives your source code, okay, and then it will not generate something called what we all know as intermediate file. Like I said, it is called an intermediate file for a reason, but then that's not the actual name. So at this point, I'm going to be giving you the actual names. Okay. Now, like I said, the first type of intermediate file is called what now? The preprocessed file. So what is being generated between the preprocessor, okay, then to the compiler is called a preprocessed file and not an intermediate file. Intermediate file varies between every two component. That is, there is an intermediate file between preprocessor and then the compiler. There's an intermediate file between the compiler and then the assembler. There's an intermediate file between the assembler and then the linker. Okay, but then that is just the general name, but not the actual name. Okay, now the actual name of the file being generated between the what is it called, the preprocessor and the compiler is called a preprocessed file. Okay, please, if you can hear me, just type something so that I will be aware that you can hear me. Okay, so the file being generated between the preprocessor and then the compiler is called the preprocessed file. Okay, it's called the pre-process file. All right, now when you open up this particular file, which is called the pre-process file, okay, so when you open up this file called the pre-process file, now what you will see is a source code after macro expansion. Don't worry, I'm going to be explaining all these terminologies. All right, so open up this pre-process file that is being generated between the preprocessor and then the compiler. Now what you are going to see is first your source code. We all know what source code are. All right, and then after macro expansion, I talked about macro on my last video, okay, where I made mention of text substitution and so on and so forth. So what you are going to see is your source code. Then after your macro expansion, then inclusion of the header files and other pre-processed directives. So if you have not watched the last video, I explained every bit of information here. So I talked about the macro expansion, I talked about the preprocessor directives, and I talked about yes. So I talked about the macro, I talked about the header file, and I'll talk about the preprocessor uh, directives. Okay, so preprocessor directive, where I made mention of the include directive, the macro definition, and then the compilation. So I touch every bit of these terms. Okay, all right. Now I'll repeat. So when you open up this particular preprocess file, all right, what you are going to see is your source code. After, you are going to see a macro expansion. So I'm going to be giving details of what macro expansion means, and then inclusion of the header files and other pre-processed directive which has been processed. All right. Now, what do I mean by macro expansion? Now, let me explain. It simply means that when you open up the macro, now macro. Okay, let me quickly give an example of what macro is. For example, you want to um add something, or let me say you want to use a long word, and then you are aware that, okay, this particular things I want to use, this particular word I want to use, uh we we be needed almost all over my mother, from a distance of A to a distance of B. So if I said run, okay, then what will happen, like, you now start running till you get to your destination. But then I don't want to be putting running on my source code. So what I will do is that I'm going to generate a short code called macro. So instead of me typing running on my source code, all I need to do is just to create a short code and name it run. So the moment I define it or put it up there, I will not need to be typing running on my source code. All I need to do is just to call run. So whenever I call run, then the your computer itself is going to automatically translate the run into run. Okay, the essence of macro. Okay, so I'm going to be explaining further though. Just okay, so I think I'm still here. All right. I thought please, if you can hear me, just type out something. Let me know, because I thought I left. Please say something, or if you can hear me, just type. Let me know whether I should continue. I'm to rush. Please just type here if you can hear me. Let me be aware. Please, if you can hear me, or just say something, please. Um, what's going on? What's going on? What's going on? What's going on? Can you hear me? Can you hear me? Can you hear me? Can you hear me? Just say you can hear me. Okay, you can. So I think we should continue, right? All right. Now let's go. Like I was saying, all right. So you might see it as macro somewhere else, and you might also see it as a symbolic name. Okay, they are different. They are the same thing. They are the same thing. All right. So don't be confused about that. Okay. So now, when you open up the macro, like I was saying, what you are going to see are substituted text. Okay, so those text is substituted. Okay, that's what you are going to see on inside the uh macro. Okay, now if I go back now, I said when you uh open up your preprocessed file, because the file, the name of the intermediate file being generated between the preprocessor and then the compiler is called a preprocessed file, right? Now, when you open up this preprocessed file, what you are going to see, like I said, first is your source code, and then macro expansion. So it is the macro expansion I'm trying to explain now. So what did I mean? When you open up the macro or the symbolic name, what you are going to see are substituted text. For example, instead of saying, okay, I gave example during my last class. So where I made mention of you saving a contact with a name, with a particular name. For example, you approach a lady or a lady approach a guy, and then you exchange contact. The first thing that will come to your mind is to save the contact with the lady's name. Okay. But then the what you need is not the lady's name. What you need is the contact. But then you save the contact with the lady's name so that it will be easy for you to find that contact. So all you need to do is just to go to your contact, search for the lady's name, and then you will see the number. Now, what you are using for call is not the name, right? What you are using for call is the number. But then you will still need to you don't want to be typing the number every time you want to make a call. Okay, so you will need the name. Name will help you to search for the number. So when you get the number, then you can now make call. So during the expansion, okay, now we are going to expand the name, because what we need is what is the contact. So the inclusion of what you are going to be seeing in your preprocessed file are number, that number you collected, this, okay, and other preprocessor directives. So those are the files you are going to see on your preprocessed file. Okay, and remember that preprocessed file is a type of intermediate file. Okay, now this particular file called the preprocessed file is being generated, okay, between the preprocessor and then the compiler. I believe this explanation is clear enough. All right, so what you are going to see, like I said, okay, so I said you're going to see the source code. So after macro expansion and then inclusion of header files, okay, and other preprocessed directives. Okay, so all these things that will be added to the source code. So the substituted text will be added to the source code plus the header files, as well as other preprocessor directives. Okay, that will also be expanded and added. Okay, so all these things will be expanded and added. So inside your preprocessor file, you'll not be seeing hash include or hash define. You're going to be seeing the actual text. Okay, so because that is what they need, all right, for them to move forward. So basically during the compilation process on the pre-process stage, okay, now there's an expansion of the preprocessor, like I said, directives, and then inclusion of the header files coupled with code. Okay, so that this particular word now file. So the expansion of the preprocessed directives and then inclusion of the header file coupled with the source code. So if you bring everything together like that, it's going to form a file called a preprocessed file. And preprocessed file happens to be a type of intermediate file. All right. So lastly, the reason why you hear almost everyone calling the preprocessed file an intermediate file is because of its extension. Now take this one. Very important. This preprocessor has an extension, okay, and then the extension is .i. So the word intermediate uh is coming from that .i. Okay, so that's why most people use intermediate file for that particular stage, but then they left it there. Okay, and then when they get to the compiler, they started using another name entirely. Okay, now the reason is because of the extension. So the preprocessed file has an extension of .i. Okay, whenever you see .i, it means it's an extension of the preprocessed file. All right, so I believe that is clear enough. I want to be fast. I don't want this thing to pass an hour. All right, so the name intermediate file is being gotten from the extension of the preprocessed file, which has an extension of .i. Okay, so the intermediate is gotten from the letter I. Okay, so that's that for that. Now let's go to the second type, or the next um types of intermediate file. Now, the first one is preprocessed file, which we just talked about. Now, the second one is called the assembly files. Okay, so let's talk about the assembly files. Now, what are assembly files? So, assembly files are files that are generated during the compilation process on the compiler. We've talked about the compilation process on the preprocessor. Now, let's talk about the compilation process on the compiler. So, assembly files are files that are generated during the compilation process on the compiler. Meanwhile, assembly files are is a type of an intermediate file. Remember when I was an intermediate file means, okay, I said it's an occurrence between two compilation components. Okay, so between the preprocessor and then the compiler and then the assembler and then the linker, there are constant generation of intermediate file. But then those intermediate files are those files are not called intermediate file. They are called some particular names. Okay, for example, the one between the preprocessor and the compiler is called the uh preprocess what is it called, files. Now the one between the compiler and then the assembler is called the assembly files. Okay, now let's talk about what assembly files means. Okay, now these are files, like I said, generated during the compilation process on the compiler. Okay, now I remember when I told you that the actual compilation process starts with the compiler. Okay, though the starting point of compilation starts with the preprocessor, but the actual work starts with the compiler. All right. So when you open up these assembly files, remember the assembly files start generated where during compilation process on the compiler, right? Now when you open up, because we want to check what is inside the assembly file so that we will know what how these things work, right? Now the when you open up this particular assembly files, what you will meet, what you are going to see are assembly codes. So I'm going to be talking about assembly codes. I'm going to be talking about the assembly language. So I'll break everything down for so that we understand, right? So when you open it, when you open up this assembly file, what you will see are assembly codes written in assembly language. Okay, so assembly code is written in an assembly language. Okay, so those assembly code are typically human readable text that represent the low level instructions in assembly language. Please don't be confused. So when you open up this assembly file, remember assembly files are files generated during the compilation process on the compiler. So when you open up the assembly files, what you will meet are assembly written in assembly language. Now, there is a reason for this assembly language. I'm going to be explaining everything, okay? So, those assembly codes, okay, are typically human readable text that represent the low level instruction in assembly language. Okay, now this code you might have seen something like called mnemonics operand. Okay, now these assembly codes are written using mnemonics and then operand. Now, the reason why they are being written using this particular stuff is because so that it will be human readable. Okay, so that you'll be able to read those code, because if you get to a point you will not be able to read them again. All right, so this particular assembly codes are written using mnemonics and then operand, okay, that correspond to a specific machine instructions. All right, now so before we look into what mnemonics and then the operand means, okay, let me quickly explain or check the meaning of assembly language, okay, so that we will know how to continue. Now, what's an assembly language? Assembly language is a low-level programming language that represent machine instructions. Okay, so we'll be talking about machine instructions. So we are going to be checking the meaning as well. So assembly language is a low-level programming language that represent machine instructions in a more human readable form. Remember, what is responsible for this human readable form are called the Ninomics and then the operand, right? Now, assembly language, like I said, can be defined as a low-level programming language that represent machine instructions, one, in a more readable form, two. Now, what are machine instructions? Machine instruction can also be called machine code. So it can be called machine code or machine instructions. Okay, so these machine instructions are the lowest level of instructions that can be directly executed by the computer hardware. Okay, so those machine code you talked about, for example, 0 1 1, okay, 1 and 0. Okay, so those things are called machine instructions. All right. So there are instructions, there are stuff that the machine carry that can be directly be executed by the computer hardware, computer processor. Okay. So there are binary codes, like I said. Okay. So 0 and 1 that also represent specific operation to be performed by the preprocessor. All right. So that is what machine instruction means. Just have it in mind that machine instructions are uh machine they are machine codes, right? They are machine code instruction which can be directly executed by the computer hardware. All right, now let me quickly list out the feature of, remember we are seeing on a assembly language. Now let me list out, call I want to like take us to where the synonyms and then mnemonics rather, and then the operand is coming from. I remember where I made mention of those two. Okay, so when I was trying to explain uh when you open up the assembly file, so what you are going to see. So I said when you open it up, what you are going to see are assembly codes written in assembly language. So those assembly language are typically human readable text that represent the low level instruction. Okay, now they say this code is written using the mnemonics, okay, and then the operand. Reason is because they want to make it um human readable. All right, now talking about assembly language. So talking about assembly language, like I said, as assembly language is a low-level programming language, right? That represent machine instruction in a more human readable form. All right. Now, machine instruction can also be called the machine code instruction, right? Which are the lowest level of instruction. Now, talking about the lowest level of instruction, it means the closest to the computer. So that is why at this point the computer can directly execute this machine code, okay, now using the computer hardware. Okay, now all these things represent specific operations to be performed by the preprocessor. Now there are some key features of assembly language which I will be stating. Number one is the mnemonics. Okay, mnemonics. All right, what's a mnemonic? So they are short symbolic code or abbreviations that represent specific machine instruction in assembly language. Now mnemonics are short symbolic codes or abbreviation that represent specific machine instruction. So for every point in time, okay, so for every machine instruction, there is a mnemonics being executed to make that machine instruction, which is the binary code, to be readable, to be human readable. So that's the essence. Okay, but it will get to a point you will not be able to use mnemonics anymore, because what the computer will be asking for will be the machine instruction and not the mnemonics. Okay, so but mnemonics at the level of assembly file, which is at the stage of compiler. Okay, they are short symbolic code or abbreviation that represent specific. So if I have one and I introduce mnemonics, it's going to translate that one to a human readable text so that you understand. All right, like I said, but it will get to a point, we will not need this particular mnemonics anymore. We are going to be the computer is going to be requesting for the machine instruction, which is the binary code itself. All right. Now, so mnemonics are short symbolic code, right? Our abbreviation that represent the specific machine instruction in assembly language. Okay. So this mnemonics acts as human readable representation of binary codes that computer processor understands. So I've already explained this part. Now let's go to the second aspects of the feature of assembly language. Now, talking about operand. Now, these are parameter or input for assembly language instructions. Okay, so they are parameters or inputs of, for assembly language instructions. Okay, now operands can also be written in human readable format or text. Okay, now what it does is that they help in specifying the data location. All right, yes, they help in specifying the data location. They will give you a location where your data is being put in place. Okay, so where your data is being uh spotted on, they are going to give you the location to the place. All right, so that is the essence of the operand. All right, so in summary, the mnemonics and then the operands are features of assembly language. There are different kind, or there are other features of assembly language, but I only pick out these two because that is what we need at the moment. Okay, still on assembly file. Now assembly file has an extension of .a or .asm. Okay, so it has an extension of .a or .asm. So the word assembly, okay, is taken from this .a. Remember I said the word intermediate is being taken from the word from the letter .i, right? So the word assembly here is taken from this extension .a, okay, or .asm. Okay, so that is where this thing is. You can proceed to make more research on this, though you can find out there are so many interesting stuff about this particular phase. Okay, so you can just go further and then check. All right, now let me talk about the we are still in type of intermediary files, right? So to talk about the preprocessed file, we'll talk about the assembly files. Okay, now let's go to the object file. Now object files are files that are generated during the compilation process on the assembler. Okay, so they are files that are generated during the compilation process on the assembler. So assembler happens to be the third component of compilation. Like yes, so it is the third man during within the compilation component. Okay, so we have the first one to be preprocessor, we have the second one to be the compiler, now we have the third one to be assembler. But in some places you might not be seeing assembler. You might just be seeing the preprocessor, the compiler, and then the linker. There are reasons to that. Okay, so because compiler, like I said, do most of the job. At some extent, it will take the assembler and then assembler and itself, and then combine everything together and then do the work. But then basically we have four compilation components. Okay, the preprocessor, the compiler, the assembler, and then the linker. All right, now as I said, still on the intermediate file. Okay, now we've talked about the first one, which is the preprocessed file, which we just finish up with the assembly file. Now let's go to the last one, which is the object file. Now object files are files that are generated during the compilation process on the assembler, right? Now when you open up these object files, what you are going to see are binary data, machine code. Remember, when you open up the assembler, you will also see some machine instructions or machine code, but there they are due to the help of the mnemonics and then the operand, we were able to read it. But here is we will not be able to read the one here because, and that's why they are called the object file. So when you open up this file, what you are going to see are binary data, machine code. Note that like I was saying, so this object file that you are seeing, okay, are typically not intended for direct human interpretation. You will not be able to interpret them because it is only meant for the computer itself. All right. So it's not for you to deal with. It's meant for the computer itself. Okay. So the place you are going to stop is the assembly file, because there you'll be able to read wherever you've written, right? But when it comes to the object file, you will not be able to do them because they are typically not intended for direct human interpretation. Are following, but instead used as an intermediate representation, okay, during this compilation process. All right. As you can see, intermediate is just appearing everywhere. All right. So that's to show you, that's to like buttress my point when I said the actual name is called intermediate. Okay. The actual name is not. All right. So let's go now. This what is it called, this object file are considered, okay, now these object files, all right. So now let me start from top. So when they say, when you open up this object file, what you are going to be seeing are binary data and machine code that are not human readable. All right, now these files, all right, are consumed by the linker. So we are going to be talking about the linker, okay, along with other object files and libraries. So when it goes to the objects, when you go to the object files, all right, where when you open up, you are going to be seeing the binary data and then the machine code. Okay, and then I said object file are typically not for you to read. Okay, so now because they are meant to be consumed by the linker along with other object files and libraries to create the final executable program. Okay, now how will I put it? So the link, I say, okay, I'm going to explain what linker means. Okay, at the end of, I'll still round up. Okay, so I'm going to be explaining what linker means. Now, object file has an extension of .o. Remember, preprocess has an extension of .i. The assembler has an sorry, the preprocess file has an extension of .i. The assembly file has an extension of .a or .asm. Now the object file has an extension of .o. So all those letters are where those are being derived from. Okay, so all those letters are where those names are being derived from. For example, from the preprocess, which is .i extension, we call it, some most people call it intermediate file, but because you know more about it, you will, instead of calling it an intermediate file, you will call it preprocess file. Okay, so when we go to the assembly file, which has an extension of .a or .asm. Okay, so we call it an assembly file because of the extension, okay, which is where the name was gotten from. Now, here we are in an object file which has an extension of .o. Okay, so the object file, the name object file is gotten from this extension as well, which is .o. So basically everything I've been saying so far, okay, basically I have explained the whole compilation components unknowingly to you, right? So in summary, for every compilation process between two compilation components, for every compilation process between two compilation components, okay, now two compilation components, I mean between preprocessor and then the compiler and then the assembler and then the linker. Okay, an intermediate file is being generated. So the file being generated between two components is called an intermediate file. But then if you go deep, the actual name of those files are not called what intermediate file, because intermediate file is just the general name, but the real name, the actual name, is not called an intermediate file. So I've already told us um why the reason for that. Okay, now like I said, let me repeat again. So for every compilation process between two compilation components, an intermediate file is being generated, right? So the intermediate file generated between the preprocessor and then the compiler is called preprocess file, like I said, all right. And then the file generated between the compiler and then the assembler is called the assembly file. So the preprocess file has an extension of .i, the assembly file has an extension of .a or .asm, all right. And lastly, the file generated between the assembler, okay, and then the linker is called the object file, all right. And this object file has an extension of .o. Okay, so what the linker does is this, is that it combines all this object file, okay, like all the object file, all the files being generated. Okay, no, the endpoint is the object file, so it will start from the preprocess down to the assembly, then lastly to the object. So everything will now turn to object file. So what linker does is that it will combine these object files and all the necessary libraries, So we all know what libraries are. Okay, so your standard, we have all those header files. Okay, all those things are library. All right, and many other libraries like that. Okay, so all the necessary library needed for that particular program. Okay, so it will combine the object file and all the necessary library into a single executable file. Now at the end, it's going to generate um an extension called .exe. So that is why your system, your Windows, okay, use .exe as an extension. For example, if you want to download something, what you see at the end is .exe, because that is the final um executable file being generated, okay, by the computer. Okay, because this is the extension the computer will now um lastly like obey. Okay, so this is what it is going to recognize, .exe, which is the last the final executable file which is generated by the computer hardware. All right, so basically that is everything about compilation model, or compilation um what is it called, component. Okay, so this is what I'm going to do. At the end of this, I'm going to create a, what is it called, I'm going to create a meet meeting. Okay, so I'm going to generate a meet linking so that we'll join, and then we can ask our questions, because if we start asking questions here, it's going to be taking a long time, which I don't want. So there, we are going to be meeting one on one in meeting. Okay, so I'm going to share a meeting link. Okay, so that everybody will join, and then you ask your question. So over there, I'm going to answer every bit of our questions. All right. So thank you very much for your time, and thank you very much for coming over. So if you have not subscribed, please make sure you do so. And for the new subscribers, I want to say a very big welcome, for the old subscribers. So thank you everybody for coming around. So I'm going to be heading the meeting now. All right. And then I'm going to generate the meeting link on Google Meet. Okay. And then I'm going to share the link so you can join and ask your question, so that it will be interactive. At this moment, at this point, I'm the only one talking. Okay. So I want it to be interactive. I want it to be an interactive session. So you can ask a question and then I'll answer it. All right. So thank you very much, everybody. And then